वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल एक्सप्लेन different topics of structure of atom like electromagnetic radiation. The first one, electromagnetic radiation. Then after we will discuss about the black body theory, black body radiation, then photoelectric effect, then Planck's quantum theory, and then after we will discuss about dual nature of matter, de Broglie's dual nature of matter, and then Heisenberg's uncertainty principle or theory. So today we will cover all these topics, 3, 4, 5, 6 topics. If we will have more time, then we will discuss some more topics. So let's start with the electromagnetic radiation. So what the electromagnetic radiation is? So as you know, the waves moves just like this, na? And this is the central point. Now have a look here. This is known as the crust, crust, and this is known as trough, TROUGH. So the height of the wave is the crest, and the depth of the wave is a trough. Now there is a different terms we have to use over here. The first is we have to use wavelength. So what the wavelength? Wavelength is what? Wavelength, it is indicated by lambda. This is lambda. So what the wavelength is? So basically the wavelength is the distance between any two consecutive crest or trough. The distance between any two consecutive crest or trough. So this is known as wavelength. So wavelength can be explained in the term of what? So have a look at this. Is the wavelength. This is two consecutive crests. So this distance is known as lambda, wavelength. So this is a distance between two trough, and this distance is known as lambda. Wavelength is the unit of the wavelength is, I just like to unit over here only. So unit of the wavelength we write in the term of angstrom, the smallest one angstrom, and that is equal to 10 power minus 8 centimeter, or this is equal to 10 power minus 10 meter, we can say. It is also expressed in terms of nanometer. So 1 nanometer is equal to 10 power minus 9 meter, and also in picometer. So 1 picometer is equal to 10 power minus 12 meter. This is also the in femtometer. So 1 femtometer is equal to 10 power minus 15 meter. So this is the unit of wavelength. Now here the next term we have frequency. So what are the frequencies? frequency is indicated by nu, N-U-E, nu. So the per second vibration is known as frequency. Vibration, per second vibration, simply we say per second vibration is known as frequency. So per second vibration is what? The vibration in 1 second, that's a per second. So unit is what? Unit basically we write nu is sometime nu, sometime nu, somewhere it is written, so you have not to worry about that. So unit is hertz, and Hertz, hertz, and 1 hertz is equal to 1 hertz. This is equal to 1 cycle per second, 1 cycle per second. So this is the frequency term. Now there is one more, is the time period. So time period is indicated by is t, and this is reciprocal of frequency 1 by nu. This is equal to 1 by nu. Unit is same, it's of the time, so in terms of per second or cycle per second. So you can say it will come above, so it will be time is a second. Now here is one more thing we have to study, that is the wave number. So what the wave number? So it is related to the wavelength. So wave number basically we can say this is the reciprocal of the wavelength. Reciprocal of wavelength. So it is wave number. It is indicated by what? It is indicated by V bar, wave number, and the V bar is equal to what? Is equal to 1 by lambda. So this is the formula you have. So this is the wave number. Now there is one more term, that's the amplitude. So what the amplitude is? So amplitude is basically the height of the crest or the depth of the trough. The height of the crest or the depth of the trough. So this is known as amplitude. Have a look here. This height is known as amplitude, or this depth is also known as amplitude. So amplitude is over here. So the unit of amplitude is the same as in term of wavelength. So unit is as in the unit of length, and that is angstrom, or in terms of angstrom, or the nanometer, or the picometer, or femtometer, just like this. So these are the terms. Now have a look here. We have a relationship between velocity of light and wavelength and frequency. So velocity of light is indicated by c, and its value, the value of velocity of light is fixed, that is equal to 3 into 10 power 8 meter per second. Now so there is a relation is what? C is equal to nu into lambda. So this is the relation between velocity, frequency, and wavelength. We can also derive it, but derivation is not required over here, so it's okay. Basically it is related to S is equal to ut. Now S is equal to ut, then u is equal to s by t, and t is equal to, as you know, time period is equal to 1 by nu, and s is a wavelength. Na? So we can write here s is the wavelength. So s can be written in terms of wavelength. That's the lambda. So lambda upon 1 by nu, this is equal to nu into lambda. So this is a u can be replaced by c, the velocity of light. So this is the relationship you have. Simple relationship. So now mostly direct questions comes from this electromagnetic radiations theory. So you should keep in mind. Now the thing is what there's something is very important part comes from here. That is how the frequency and wavelength is related. So if the velocity is the constant, then nu is inversely proportional to the lambda, means so we can say frequency is inversely proportional to wavelength. So if the frequency increases, then wavelength will decrease. This thing you should keep in mind. Now have a look here. One type of the question is always asked, like they will give you the electromagnetic spectrum and you have to find out, just arrange this in increasing order, decreasing order of the wavelength, or the increasing or decreasing order of the frequency. So I'm just giving you some way over here. So like we have like this, like cosmic rays, gamma rays, X-rays, ultraviolet rays, visible rays, then infrared, and then microwaves, and this is the radio waves. Infrared, microwave, and radio waves. Now have a look here. So suppose this is the different waves. So now we put wavelength. The wavelength is, this is in 10 power minus, in between 10 power minus 16 to 10 power minus 14. This is in between 10 power minus 14 to 10 power minus 12. This is 10 power minus 12 to 10 power minus, here 10 power minus 8, sorry, is 10, then 10 power minus 8. Ultraviolet, 10 power minus 6 is in 10 power minus 8 to 10 power minus 6, and here is the 10 power minus 4, 10 power minus 2, 10 power 0, 10 power 2, and 10 power 4, just like this. Now have a look here. If you think about the nu is in per second, per second vibration, the unit is per second, and lambda is in meter. So it is 10 power 24, 10 power 22, 10 power 20, 10 power 18, 10 power 16, and then after 10 power 14, 10 power 12, 10 power 8, 10 power 6, 10 power 4, just like this. So now what you are observing over here, lambda, the value of lambda from cosmic to radio wave is increasing, and the value of frequency from cosmic wave to radio wave is decreasing. So this is a thing you should keep in mind. This is the visible ray. Where the visible ray is, this is the visible ray. So visible ray, when you talk about the visible ray, so visible ray also have a different color. This is not the Vibgyor, if you remember. Vibgyor, Vibgyor, like violet, indigo, blue, green, yellow, orange, and red. Now we just discuss about its frequencies and wavelength again. So lambda in terms of meter and the frequency in terms of per second. Na? Okay. So this is 380 meter, 430, 430, 430, 450, 450, 490, 490, just like this. They have given 560, then 590, 590 over here, then orange near 650, and the red 760 in between. Now this is the wavelength they have given you. So you should keep in mind that the wavelengths only. So vice versa you can do. No? So this is about the this is in nanometer. You should keep in mind this is the values are in nanometer. Nanometer. So what you are observing in this case, so wavelength is increasing from violet to red. It means frequency will decrease from violet to red. Na? That's why red color is used. It have a very much high wavelength. So red color is used as a danger indicator, na? Or in signals. Na? So because the deviation of red light is very less, and it have great wavelength, so it can be observed very easily from far. Now, so this is one type of the question will come from this one. You have to arrange this one according to their wavelength or the frequency. Na? So whatever it will given to you, so you have to do accordingly. Now I will just move to us. We are not. Question is very direct. Question will come from the formula, and that will what the formula we have. We have the formula C is equal to nu into lambda. There is one wave number is equal to 1 by lambda, and there is equal to time period is equal to 1 by nu, and the nu, as you know, is the so these are the these are the what these are formula on based of this different question can be solved. Now you should keep in mind the value of C is equal to 3 into 10 power 8 meter per second. So this is the thing regarding this. Now we'll just study about the black body radiation theory. Now, electromagnetic wave theory didn't explain something about the black body radiation theory, photoelectric effect. Now, so we have to study one by one, and then have a look here. Then we'll just come to the point black body radiation theory. Black body radiation theory. So what the black body radiation theory? So simply when you heat something, when you heat something, suppose here the some metal, suppose here the iron, we took the iron, and we heat it, so it absorbs the heat and reflects some particular type of wavelength or frequency. Accordingly, what is the reflected frequency? That shows a particular color. As in the case of the iron or the iron bar. So when you heat it, then first it will convert into red color. Then it will become into yellowish. And then glow with a white. And finally it will come into the blue. And that's finally it will come into the black. So this is the black body radiation theory basically states that when you heat something, then it will show the different color at the different level of heating, because the different energy will absorb at different level of heating. And that reflects whatever the wavelength or the frequency reflects, accordingly the color have been absorbed. Now, so basically we can say there is one more thing. Black body radiation theory states that black body is a perfect absorber as well as perfect emitter. No? So black body is a perfect absorber as well as a perfect emitter. Wait a second. Now suppose we have taken the graph like this. So here we put the wavelength this side, and here the intensity of heat, intensity. So what we observe, the different temperature, the different wavelength is observed. So at particular T2 temperature, this much is wavelength. At the T1 temperature, the wavelength is somewhat other. So T2 at the T2 temperature, there will be more wavelength other compared to the T1 temperature. So this is the black body radiation theory. Now we will just discuss about a term, photoelectric effect. Photoelectric effect is what? Photoelectric effect. So photoelectric effect when you just take a metal, this is a metal surface. When a suitable frequency of light falls on a metal surface, then electron get ejected. When a suitable frequency of light falls on a metal surface, so the electron get ejected. This phenomena is known as photoelectric effect. So what you say, when a suitable frequency of light falls on a metal surface, electron get ejected. So the phenomena of ejection of electron when a suitable frequency of light falls on a metal surface is known as photoelectric effect. For different metals, this suitable frequency of light must be different. Like when we talk about cesium, potassium, sodium, so the frequency of light will be different. But before that, I would just like to explain you threshold frequency, threshold energy. But before that, I will just come to this point again. But before that, I would just like to explain one more theory, and this is known as the Planck's quantum theory. Then we'll just back to the photoelectric effect again. First, Planck's quantum theory. So what the Planck's quantum theory? So what the Planck's quantum theory? So Max Planck have given this theory in 1900 around. So he have, quantum means what? Quantum, they have used a term quantum over here. Quantum, this is related to what? Energy, and energy is what? Energy for the light, the unit of energy, light is also the source of energy. So for the light, the unit will be photon. He has used the term photon over here. So according to him, the energy of each quantum, each quantum is what? Quantum is basically small packets. So Planck's quantum theory states that light travels in bundles, na? And light is discrete. Discrete means what? Discreted means light is light moves all around. So this is discrete, means splitted, we can say. Na? So light travels in bundles or packets, and light is discrete, means it is splitted. And so he also told the energy of the light is directly proportional to the frequency of its frequency. So whatever the energy depends upon the frequency of that. So we have used the term E is directly proportional to nu, and so E is equal to h nu. Na? So h is the proportionality constant, and this h is known as Planck's constant. And the value of Planck constant is always fixed 6.626 into 10 power minus 34 joule second. This is not joule per second. Always students get mistake, so you should keep in mind joule second. Now so this is E is equal to h nu. So this is the Planck's quantum theory. E is equal to h nu. Now we can, as you know, the C is equal to nu into lambda. So nu is equal to C by lambda. We can write over here. So E is equal to C is equal to nu into lambda, then nu is equal to C by lambda. So h C by lambda we can put here. So this is true formula you will get. So on the basis of this formula you can solve some question. We will discuss about this question later on. First, just move towards the photoelectric effect. So what the photoelectric effect we studied? Then we studied about the photoelectric effect. When a suitable frequency of light falls on a metal surface, electron get ejected. This is known the photoelectric effect. Wait a second. So this is the metal surface. Suitable frequency of light falls on it, electron get ejected. Now have a look here. So whatever the light it will use, so that must have energy. So we use the total energy. Some amount of energy required to remove the electron, to eject the electron from the metal surface, and this energy is known as threshold energy. This energy is known as threshold energy. And sometimes we also say the work function. This is also known as work function. So now rest of the amount of total energy will remain with the electron in the form of kinetic energy. So we can write it over here E total is equal to E naught. Threshold energy represented by E naught plus kinetic energy. So first we just write. You can write over here about the threshold energy. Threshold energy is what? So the minimum energy required to eject the electron. Energy required to eject the electron from the metal surface is known as threshold energy, or sometimes it is also written as W naught or the wave function. Now here is one more thing, that is a threshold frequency, nu naught. This is known as threshold frequency. frequency. So threshold frequency is what? The minimum frequency required. The minimum frequency of light, obviously, of light required to eject the electron from metal surface. So this is known as threshold frequency. Now come over here. So E total, as we know, then E directly proportional to nu according to Planck's quantum theory. We studied now quantum theory, and the E naught will directly proportional to nu naught. So we can write over here that E is equal to h nu and E naught is equal to h nu naught. No problem. Putting this value, kinetic energy is written as half mv square. So E total in place of E total we can write here h nu, and this is equal to h nu naught plus kinetic energy. So if you want to find out the kinetic energy of the electron, so it will be h nu minus h nu naught. So we can take the common h, nu minus nu naught. So this is half mv square. So this is the formula. With the help of we have to solve some question based upon photoelectric effect and quantum theory. So from this usually in Cbse direct questions comes like what the formula you have the formula E is equal to h nu or E is equal to h c by lambda. Somewhere the value of nu will be given, or somewhere the value of lambda will be given. So you can use both the formula to find out the energy of the electron. Now, sometime what happens, the question comes from the photoelectric effect. So the kinetic energy is equal to, as you know, h nu minus nu naught. So you can find out the kinetic energy. Now if they want to find out the velocity of the matter, so you can use half mv square is equal to h nu minus nu naught. Nu naught will be given. Planck constant you should always keep in mind, that is 6.626 into 10 power minus 34 joule second. And so mass of the electron 9.11 into 10 power 31 kilogram. That is velocity you can find out with the help of this formula. So this is one type of the question. This is a different type of the question they can ask you from these two topics. Now we'll just move towards the next one, and the next one we have dual nature of matter. So what's about the dual nature of matter? So as you study about the Bohr's atomic model, so they have not explained about the dual nature of matter. So what is the dual nature of matter? Dual nature of matter. So dual nature of matter is what? So it was given by de Broglie. Who have given? De Broglie. Dual means two types of nature. De Broglie was a French scientist, physicist basically. He's a physics. He's related to physics, so he's a physicist. So de Broglie, he have given this concept in 1924. He have taken this concept from Einstein. Einstein in 1905 he suggested about the light, and light have two types of nature, two types of character, wave character and particle nature. And as you have seen the torch, you just put a torch on a wall, so it will show you the concentric circle, just like it. Just if you move the torch from forward and backward on the wall. So you will observe a concentric circle. So by watching such type of the concentric circle, this shows a wave character. And particle character, it already have the light. When the light falls on anything, then it generates energy. So like students usually use the prism. When they use the prism, and suppose here the paper, and here the sunlight. By using the prism, what will happen? The paper can burn. So this indicates that it must have a particle nature. So Einstein have suggested about the light, but D. Broglie have taken his concept and he have used it for matter. So D. Broglie told that if light can have two types of nature, then matter must have a two types nature, wave and particle. So now this is not easy to say only, to take the concept only. You have also to prove it. So how he proved it? So D. Broglie have taken the help of the experiment done by some others, and he have taken the as evidence in support of his concept. So there were scientists Davison and Germer. Davison and Germer. So he have given an experiment X-ray diffraction pattern. He have given the experiment X-ray diffraction pattern. So what he have done in the X-ray diffraction pattern? So he have taken the source of light. Suppose he have taken a metal surface, and he have bombarded the light over here, and the electron get ejected. When the electrons are taken on the spectrum, so he observed such type of concentric circle. So such type of concentric circle, a ring of alternative intensity. This is the diffraction pattern. So it gives a when he have taken on this on a spectrum, so he got such type of concentric circle. So with the help of this concentric circle, so basically this is a nickel crystal. It is the nickel crystal. He have taken nickel. So this concentric circle, with the help of concentric circle, he proved that the same pattern have been observed in the case of light, and here also the same pattern have been observed in the case of electron. Because the electron gets ejected, this electron shows concentric circle pattern. So it proves that matter have a wave character. Now he have to prove the second thing, the particle nature. So how he will use this? So he have taken the help of J.J. Thomson experiment. Thomson's experiment. If you remember, discovery of electron. So what he did? So suppose this is the cathode ray experiment. Basically, we say it cathode ray experiment. This is cathode. This is anode. As you know already, this is the discharge tube. The pressure is reduced from 180 m, and the volt is 10,000 volt. We have taken 10,000 volt. So cathode ray comes out from here. So as a cathode ray comes out from here, then we just put a thin metal wheel over here. So this metal wheel get a start rotation. So when anything will get a rotation, so rotation anything will get when there will be impact, and when there will be impact there will be force, and when there will be force, there will be mass. So where there is a mass, there is a particle nature. So with the help of this, we can find out that since it strikes on the metal wheel and it gives its rotation, so since cathode ray is nothing is the electrons, and electron is a matter, so matter have also the particle nature. No? So there is one more experiment. It was a scintillation experiment. Scintillation experiment is what? It is just like this. This is the zinc sulfide plate, and when a suitable frequency, and we bombard the electrons now over here. So when we bombard and stop the bombarding, after stopping the bombardment, we observe some spot over here, spots. When a spot is created, when you impact on that, then you are applying a force. When force is there is a mass into X-ray. Where there is a mass, there is a particle nature. So these two experiments, second and third, scintillation experiment and a cathode ray experiment, the Thomson experiment, that is a cathode ray experiment. Both experiments prove the particle nature of the matter, and Davison and German's X-ray diffraction pattern shows wave character. So de Broglie have proved that matter have both the character wave as well as a particle. Not only he have proved it theoretically, he have also proved it. He have also given a mathematical relation. What the mathematical relation is? So he told that according to Einstein. So what the Einstein told? Na? So Einstein have given the concept relativity law. Then Einstein have told that E is equal to mc square. Planck's quantum theory told that E is equal to h nu. What he did, he told both are the energy. So equation 1 is equal to equation 2. So you can write here the mc square is equal to h nu. Acha, as you know, C is equal to nu into lambda. So nu is equal to C by lambda. Putting this value in equation number 3. So mc square is equal to h c by lambda. 1c is cancelled. So mc is equal to h by lambda. Now we are discussing about the velocity of matter. So we can replace c to the v. This v is the velocity of matter. C is the velocity of light. So now what we will do? So we just take the mv is equal to h by lambda. So lambda is equal to h upon mv. So this is the equation he got. So this is known the de Broglie's equation. De Broglie's equation, and this is known the de Broglie's wavelength. This is what? De Broglie's wavelength. Acha. We can also mass into velocity is what? Momentum. So lambda is equal to h upon p. There is always one question is asked, like when it is very difficult to find out the wavelength when the cricket bowler balls. When the cricket bowler balls, then what happens? So what the question is? Question is, it is difficult to find out the wavelength of cricket ball when the bowler balls it. When the bowler balls it, it means it must have some velocity. Lambda, we have the formula lambda is equal to h upon mv. So it must have some velocity. So velocity is inversely proportional to lambda. So as far so it and the mass, there must be some mass of the ball, and the mass of the ball usually is 400 gram or something, like 300 gram, whatever. Now lambda v must be in some 100 km per hour 100 kilometer per hour, 200, 140 kilometer per hour, like this, na? So this is the speed of the ball by the cricketers. So since the mass is also very high and the velocity is also very high, though product will also very high. So since this product will, the value of this will very high, so the lambda, which is inversely proportional to this one, so it will difficult to find out the values of lambda will be very, very low, na? Because the value of mass and velocity is high, so the value of lambda will be very, very low. So it will difficult to find out the wavelength when the bowler balls. So this concept, the answer of this question can be solved with the help of this formula only. Now have a look here. So now you can also solve questions based upon this one directly. So what the formula you have? So you have what the formula you got? De Broglie's equation. So de Broglie's lambda is equal to h upon mv, or the lambda is equal to h upon p. If the momentum is there, then you can also find the momentum. Now, so the h is always constant. So you should keep in mind the values of h. This is always constant. So the direct question will come in the Cbse. Now there is one more concept, that is the Heisenberg uncertainty principle. Heisenberg's uncertainty principle. So what the Heisenberg uncertainty principle? So Heisenberg uncertainty principle states that, but before that, I just like to give you some example. Now, have a look here. We are discussing about the macro things, like suppose here is an athlete who is at his starting point. So he is about to run. So we know what the exact position he have, but we don't know exact velocity what he have. Now, because he is only at a starting point, he is moving a little bit over here. Now, but when he will start running, then we know with what speed he is running. Suppose he is running with a velocity 50 kilometer per hour, like this, or 100 kilometer per hour, whatever. So we know the v, but do you think we know the exact position of that athlete? No, we don't know the exact position of that athlete, because each and every moment he is changing his position. So we don't know the exact position of his that athlete. So it is difficult to find out both the thing, what position and velocity of a body at the same time, exactly at the same time. So it is impossible to find out the exact value of position and velocity of a body. But this is about the macroscopic body, which we can see. Now we are discussing about the microscopic body. Microscopic body is like electrons. We are discussing about the electrons. Suppose electron is over here. Electron is moving around the nucleus. Now, what we need to see something? We need eye as well as light. Light is what? Visible light. So when the visible light, as you discuss the frequency wavelength of the visible light, so when the visible light falls on the electron, the mass of the electron is very, very less. Is 9.11 into 10 power minus 31 kilogram. So it's very, very small, very small. So when the visible light falls on the electron, since its mass is very light, so it will change its path. So it will very difficult to find out. It is almost impossible to find out the exact position of the electron. So you can't see the exact position of the electron. So Heisenberg he have given the concept. He have told that it is impossible to find out accurately the position and momentum of a microscopic particle simultaneously. So it is difficult to find out the position and momentum of a accurate position and momentum of a microscopic particle simultaneously. So you have given the term delta x into delta p is equal to h upon 4 pi. Somewhere it is equal to the greater than. Is equal to or greater than. So here the delta x is uncertainty in position, whereas delta p is uncertainty in momentum, h is equal to Planck's constant, pi is equal to 3.14. Now have a look here. Now, as you know, delta x, momentum is what? Momentum is mass into velocity. Mass will not change, but there will be change in velocity. Mass into velocity, we can write here. So this is equal to m into delta v, that is equal to h upon 4 pi. So this is the formula he have given. So with the help of this formula, you can solve some question. So whatever the question they will ask, so the question they will ask, either they will give you the uncertainty in position, and they will ask you find out the uncertainty in momentum, just like this. Okay, I'm just giving one question related to this one. So like the NCERT question. So a golf ball has a mass of 40 gram and speed of 45 meter per second. If the speed can be measured within accuracy, if the speed can be measured within accuracy of 2%, calculate what you have to calculate the uncertainty in position. So how will you solve such type of the question? If the such type of question is given, then first write down the values which I have given. So accuracy of uncertainty. So uncertainty in speed. Uncertainty in speed they have given. This is equal to 2%. 2% of what? 2% of 40 meter per second. They have given a golf 45 meter per second. Sorry. The what? 45 meter? Yeah, 45 meter per second. So 45 meter per second is 45 meter per second. That is equal to 2 by 100 into 45, and it will come what? 90 upon 100. 90 upon 100 means 0.9 meter per second. So delta V, you got it. Delta V means you got it, this one. Now to find out delta x, you use this formula. So I can write, I'm writing over here only. So delta x is equal to, what will the delta x? So delta x is equal to, with this formula, h upon m into delta v into 4 pi. Put the values, you will get the answer. What the values are? So your values for the h is 6.626 into 10 power minus 34 divided by mass of the electron. As we know, then this is what? Mass of, this is not the mass of the ball. They have already given 40 into delta v. You got 0.9 into 4 into in the place of pi you can 3.14 you can use. When you use these all values, one thing is this value is given in the gram, so you have to convert it into kilogram first, because SI unit is the kilogram. So 40 into 10 power minus 3. So this is the value. You should keep in mind these things are very, very important for the conversion point of view. Gram into kilogram or something like this. So otherwise your answer will be wrong. So when you solve this, so what your answer will come near about 1.46 into 10 power minus 33 meter. So such type of the question will ask paper. So now today we have covered so many things. The first one is let's revise once, so it will more convenient for you to understand everything. So today we have started from electromagnetic radiation theory. So this is, let's revise once. So this is we have started with the electromagnetic radiation theory. So then black body radiation theory we covered, then photoelectric effect, Planck's quantum theory, then de Broglie's dual nature of matter, and Heisenberg uncertainty principle. So this is the wave, and the wave have the crest and trough, the wavelength, the distance consecutive, the distance between any two consecutive crest or trough, and its unit is in angstrom, nanometer, picometer, just like this. Again, the frequency per second vibration is indicated by nu. The unit is cycle per second, or simply we can say per second. So unit is per second, we can write over here. Time is 1 by nu. So 1 by nu is what? Nu have the value is what? 1 by per second. So it will be second. So for the time, the unit for time period is equal to second. Now again, wave number, reciprocal of wavelength is a wave number, and its unit is same as a unit of wavelength or the length. Okay, now amplitude, the height of the crest or the depth of the trough, its unit is the same as the length. It may be angstrom, nanometer, or picometer. Velocity of light, as we know, c, and we proved it with the help of a formula s is equal to ut. So we have put in place of s we have put the lambda, and in the place of time period we have put 1 by nu, and so you got c is equal to nu into lambda. And we also discussed about the relationship between frequency and wavelength. Frequency is inversely proportional to the wavelength. So as the frequency will increase, wavelength will decrease. So this is the different waves, and as you know, the wavelength is increasing from cosmic to the radio, so the frequency will decrease from cosmic to radio. And this is the Vibgyo. So wavelength is increasing from violet to red. Now, so this is the formula, and this on base of this formula you have to solve direct question. So direct question come into the Cbse, but you should keep in mind the value of velocity of light. This is 3 into 10 power 8 meter per second. Now the black body radiation theory we study. Then everything, when you heat something, some metals like iron or anything, then its color will changes as it will absorb the heat. Because whatever the amount of the heat, whatever the frequency of the heat is required, it will absorb accordingly it would reflect the different type of wavelength or the frequency. So the color is also observed different. So as in the case of iron, the color is red, yellow, white, blue, and finally it's black. When you heat something, anything, so finally its color will be black. So black body is a perfect absorber as well as a perfect emitter. So at the different density, intensity of the wavelength, it will show the different wavelength. Now the photoelectric effect, when the suitable frequency of light falls on a metal surface. So this is the photoelectric effect we have. Now again, this is Planck constant theory. Then the light travel in bundles of packets, and second, light is in discrete, means it's splitted, and third, he told that energy of the light is directly proportional to the frequency, and where the h is the Planck constant. Its value is 6.626 into 10 power minus 34 joule second. You should keep in mind. Now this is the formula related to Planck's quantum theory. Now photoelectric effect, again we just moved to the photoelectric effect, and we told that there is some terms like threshold energy and the threshold frequency. Threshold energy, also known the wave function, this is the minimum energy required to eject the electron, and where the threshold frequency, the minimum frequency required to eject the electron for the metal surface. And this relationship we concluded that E total is equal to E naught plus kinetic energy. In place of E we put h nu, and in place of E naught we put h nu naught, and put the value, we got half mv square is equal to h nu minus nu naught. And so with the help of this formula we have to solve the numericals. Next we have a study about the dual nature of matter. So it was given by de Broglie. The concept was taken by, from Einstein's, as the Einstein suggested about the light have the two character, wave and particle. De Broglie also taken his concept, and he proved that matter will also have a two character, wave and particle, and he proved with the experiment done by some others like Davison and Jama. He have done the X-ray diffraction pattern. So concentric lines shows the wave character as in nickel crystal. This is the nickel crystal when a suitable light falls on it. Thomson's model cathode ray experiment, and with the help of cathode ray experiment he proved the particle nature. When the cathode ray strikes on the metal wheel, then there is rotation took place. A rotation, when it will rotation, that will be impact where the force with the where the force there is a mass, where there is a mass there is a particle nature. And scintillation experiment also proves when zinc sulfide plate have been taken and it is bombarded by the electrons. Now, and after bombardment some spot is observed. Again same concept is over here. Now, so this is the not only he have proved it theoretically, he have also proved it. He have also given a mathematical relation. So he have given, Einstein have given E is equal to mc square. Planck's quantum theory gives E is equal to h nu. So he have equated this one, and finally he got the relation. So lambda is equal to h upon mv. This is known the de Broglie equation, and this wavelength is known as de Broglie's wavelength. Now, so we have also discussed about the cricket ball concept. The cricket ball, it is difficult to find out the wavelength of cricket ball when the bowler balls. Why? Because the cricket ball must have some mass, which is bigger one, and it must have the velocity, which is also a bigger one. So more and more velocity and the mass it will have, it will less possibility of finding the exact wavelength, because it is inversely proportional to each other. Now the Heisenberg uncertainty principle, we discussed about the macro. Macro means about the athlete. When an athlete at the starting point or when he runs, so it is difficult to find out both the position and momentum at the same time. Same concept we have used for the microscopic particle, that electron, as I told you. So when you see the electron, since the mass of the electron is very less and the visible waves falls on the electron, so it changes path. So we can't find out the exact position of the electrons at any time. So this is the concept. Heisenberg uncertainty principle is given by lambda x is equal to lambda p is equal to h upon 4 pi. This is the uncertain position. This is the uncertainty momentum. And since mass do not changes, there is only change in the velocity. So you can also write delta x is equal, delta x into m delta v is equal to h upon 4p. And we have also solved some question on based upon this Heisenberg uncertainty principle. So for today we have covered all the concept what we have from where we have started. So we will meet in the next video with some other concept, with the other topic of the different chapter. Till then, goodbye. Take